Dear students, in our last lecture we have studied how to find out the inverse of a given matrix by using elementary transformations. In that lecture I have explained two examples of matrices. One is of order 2 by 2 and other is of order 3 by 3. By row transformations as well as by column transformations we have discussed how to find out the inverse of those matrices. Okay, today we are going to study another method, that is adjoint method, to get the inverse of matrices. Okay, so let us see. Our concept is inverse of matrix, and in that now we are going to study adjoint method. This is another method to find out the inverse of matrix. Before going to study the adjoint method, we will discuss or we will study main points related to this method. So our first point is we have to study how to find out the minors and cofactors of elements of the matrix. This is our first concept. Then second one is cofactors matrix, and then how to get the adjoint of matrix. So today in this lecture we will discuss all these 3 points related to the method adjoint method. Okay, so we will discuss this by one example. So let's see. First of all, we will study definitions of minors and cofactors. So see here, what do you mean by minors? So minor of an element Aij of matrix is the determinant obtained by ignoring ith row and jth column in which the Aij element lies. Means minor is the concept related to every element of matrix. Suppose the element is Aij. Suffix denotes row number and column number. So if the element is Aij, then how will you get minor of that element? It is obtained by taking the determinant by ignoring ith row and jth column in which Aij element lies. And minor of that element means minor of Aij is denoted by capital M suffix ij. We will discuss this in detail by taking one example. Okay, so this is just a definition of minor. Similarly, we will see the definition of cofactor. So see here, cofactor is also related to every element of matrix. So cofactor of an element Aij of matrix is given by, it is generally denoted by capital A Ij. And how will you get that? It is minus 1 raised to I plus j, where I and j, I is called as row number and j is column number. Minus 1 raised to I plus j into capital Mij, where we know that Mij is the minor of element Aij, and cofactor is denoted by capital Aij. So cofactor is related with or related to minor of element. Okay, so to get the cofactor of any element, first of all we need to find out minor of that element. See here the formula, it is minus 1 raised to I plus j into Mij. Okay, now we will discuss this in detail by using the example. Okay, so let's see. Suppose matrix A is given to you. A is equal to 2 by 2 matrix 2 1 3 minus 4. See, Here in general, how will you write A11, A12, A21, A22 like this. Now we will find out minor of every element of this matrix. So let's see. So minors of elements of given matrix are, now first minor of A11 is denoted by M11, means we are going to calculate the minor of this element. How will you get the minor of this element? By ignoring the row and column, corresponding row and column. Now if you ignore the row and column here, or if you remove this row and column here, then you will get a single element, that is -4. Actually we have to find out its determinant, but here in case of 2 by 2 matrix we get single element. So after removing row and column corresponding to this element, we get minor of that A11 is equal to -4. Remember, so this is the minor of this element. Then next, minor of A12 denoted by M12, it is equal to, see, minor of this element, minor of this element. By ignoring row and column, you get just this element, that is 3 here. So directly you can write the minor of A12 is equal to 3. Then minor of this element M21, here minor of A21 means this element. How will you get that? Ignore this row and column and remaining element is 1. So this is the minor of A21. It is denoted by M21. Then last one, minor of A22, minor of this element. Again remove row and column and remaining is the single element, that is 2. So here just in case of minor we have to remove the row and column, corresponding row and column of that element, and we will find out the determinant of remaining part. But here in case of 2 by 2 matrix we get a single element, that's why you will get the direct minor of that element. So this is M11, M12, M21, M22. Serially you have to find out like this. Okay, so there are 4 minors of 2 by 2 matrix like this. Okay, so clear the definition of minor first of all here by this example. Now we will see the cofactors. So cofactors of elements of given matrix are, see, first cofactor, that is capital A11. How will you get that? That is called as cofactor of A11, cofactor of this element. By the formula it is -1 raised to 1 plus 1 I plus j. Here suffix are 1 1. So -1 raised to 1 plus 1 into M11. So A11 is related to M11. So see the calculation here. -1 raised to 1 plus 1 into bracket. What is M11? See here. It is -4. Okay. Now what about -1 raised to 1 plus 1? It is -1 raised to 2. So -1 raised to 2 is plus 1. So plus 1 into -4, that is -4. So see here, this is the minor M11 is equal to -4. Then cofactor will be -4. Just compare this M11 and A11 like this. Then next one, see, A12, that is the cofactor of A12. Now how will you get that? By the formula it is -1 raised to 1 plus 2. Here suffix is 1 2. So -1 raised to I plus j, that is here 1 plus 2 into M12. Now see here, what is M12 here? It is 3. So just put that value. So minus 1 raised to 1 plus 2 into 3. Now what about minus 1 raised to 1 plus 2? So it is minus 1 raised to 3, and minus 1 raised to 3 is minus 1. So minus 1 into 3, that is equal to minus 3. So here in this case, minor of A12 is equal to 3, but cofactor is equal to minus 3. Minor is 3, but cofactor is minus 3. See here. Then next one. Cofactor of A21. Here it is capital A21. How will you get that? Minus 1 raised to 2 plus 1 into M21. Now see here, M21 is 1. So next step in detail, it is minus 1 raised to 2 plus 1, because suffix is 2 1. So 2 plus 1 into 1. So minus 1 raised to 2 plus 1 is minus 1, because minus 1 raised to 3 means minus 1, and hence we get minus 1 into 1, that is minus 1. So again compare this. Minor is 1 and cofactor is minus 1. Similarly, last, that is cofactor. Cofactor of A22, that is equal to minus 1 raised to 2 plus 2, because suffix is 2 2. So minus 1 raised to 2 plus 2 into M22. Again put the values. So minus 1 raised to 2 plus 2 into, this is minor, that is 2. Now minus 1 raised to 2 plus 2 means minus 1 raised to 4, and minus 1 raised to 4 means it is plus 1. So we have to multiply by 1. So 1 into 2 is 2. So again here minor is 2 and cofactor is also 2. So cofactor is just, you have to either multiply by minus 1 or by plus 1 to minors. Okay. So if you observe this, then it is just minus 1 raised to 1 plus 1, or minus 1 raised to 1 plus 2, minus 1 raised to 2 plus 1, or minus 1 raised to 2 plus 2. Whenever the index of minus 1 is even number, then you have to multiply the minor by 1. And when the index is odd number, index of minus 1 is odd number, then you have to multiply the minor by minus 1. So just if you compare minors and cofactors, then it is very easy to understand. So see this comparatively. So this is all about minors and cofactors of every element of given matrix. So there are 4 minors and corresponding 4 cofactors. Now we will find out the cofactors matrix. So again see here, this is given matrix. This is minor, that is minus 4. Its cofactor is again minus 4, same. Then M12 is equal to 3, A12 is minus 3, M21 is equal to 1, and A21 is equal to minus 1, M22 is equal to 2, and A22 is equal to 2. So in short, minors and cofactors, you can write like this. Now we will create matrix of cofactors. So how will you write the matrix of cofactors? This is our next concept. So matrix of cofactors is equal to, here in this case, write capital A11, A12, A21, A22. So we get the matrix of cofactors can be denoted by capital Aij, that is equal to, see here, minus 4, minus 3, minus 1, 2. Okay. So after finding minors, we get cofactors, and then we get the matrix of cofactors like this. Now what about adjoint? The adjoint of matrix is always transpose of its cofactors matrix. Now here we get this is the cofactors matrix. Just by taking its transpose, means transpose of this matrix is called as adjoint of matrix. That is, see here, transpose. How will you write transpose? It is symbolically, it can be written as in bracket aij raised to t. It is equal to adjoint of a. See, it can be denoted by adj dot a, adjoint of a, like this. So here in this case, if you take the transpose, means just by interchanging rows and columns. So here we get minus 4 minus 1 minus 3 2. So this is the example of 2 by 2 matrix. So we get minors and cofactors. Then we get the matrix of cofactors, and by taking its transpose we get the adjoint of that matrix. So this is the adjoint of the matrix. Okay. Now we will discuss another example of for 3 by 3 matrix. So let us take one example of 3 by 3 matrix. How to find out the minors and cofactors of this 3 by 3 matrix. So the given matrix is like this: 1 2 minus 1 2 1 3 1 minus 1 minus 2, and in general we can write like this. Now as per our definition, first of all we will find out minor. So minors of an element of given matrix. So here there are 9 elements. See here, in this case there are 9 elements. So we will get 9 minors and 9 cofactors. Okay. So serially, how will you find out? First of all, we will find out minor of A11. See here, minor of this element. Now our procedure is what? We have to ignore this row and column. Now in case of 3 by 3 matrix, if you ignore row and column, then we have to find out the determinant of remaining elements. Now remaining elements are 1, 3, minus 1, minus 2. So here in this case, to get the minor of A11, we have to find out the determinant of this determinant of this remaining elements. Okay, so 1 3 minus 1 minus 2, like this. In case of 2 by 2 matrix, just directly you will get the minor, but in this case we have to find out its determinant. Now it is very easy. How will you get the determinant? It is 1 into minus 2, that is minus 2 and minus 3, minus 2 and plus 3, we get 1. See the calculation. You know how to find out the determinant of this element. So 1 into minus 2 minus 3 into minus 1, so minus minus plus, so minus 2 plus 3, that is 1. Okay, so this is minor M11. Next, minor of this element, that is minor of A12. So minor of this element, remove this row and column, write the other elements. Other elements in this case are 2 3 1 minus 2. See here carefully, 2 3 1 minus 2. Now what is the determinant of this? 2 into minus 2, that is minus 4, and minus, this is 3 into 1, that is 3. So minus 4 minus 3, that is minus 7. Okay, clear? Now next, minor of A13, minor of A13, see here. So how will you get minor of this? Again remove this row and column, write the other part in the determinant, that is 2 1 1 minus 1, and find out the determinant, then you will get minus 3. So first row is completed. Minor of A11, then A12, and then A13. Now come to the second row. minor of A to 1 here. A to 1. Remove this row and column. Okay. Then write other part here. 2 minus 1 minus 1 minus 2. See here carefully. 2 minus 1 minus 1 minus 2. So what is the calculation here? For the determinant, it is 2 into minus 2 is minus 4. Minus 4 and minus 1 into minus 1, that is plus 1. So minus 4 minus 1, that is minus 5. Okay, see the calculation. Then next, minor of A to 2 means minor of this element. Again remove row and column. So that is 1 minus 1, 1 minus 2. See here, check this. 1 minus 1, 1 minus 2. And after the calculation, proper calculation, we get minus 1. Then next one, minor of this element, minor of A to 3. See here, minor of A to 3. Again ignore row and column. Then remaining part is 1, 2, 1 minus 1. 1, 2, 1 minus 1. And see the calculation. By calculation you will get the determinant, that is minus 3. Okay, so second row is also completed. Then come to the third row. Here minor of A31. Minor of A31 means minor of this element. Again remove row and column, same procedure. Write the other part, that is 2 minus 1, 1, 3, and its determinant will be, see here, it is plus 7. Okay, so this is M31. Then next one, minor of A32. Minor of A32. Again remove row and column. Then it is 1, 2 minus 1, 3. See here, 1, 2 minus 1, 3. Calculate the determinant, that is 3 minus minus 2. 3 minus minus plus 2, that is 5. Okay. Then last one, minor of this element, that is minor of A33. Again remove row and column. Then other elements are 1, 2, 2, 1. Write it in determinant form, that is 1, 2, 2, 1. So its determinant is 1 minus 2 into 2, 1 minus 4, that is minus 3. So there are 9 minors of every element of given matrix. Okay, so here actually we have to find out the determinant. So see carefully. Now we will find out the cofactors. So we here first of all M11, that is minor M11 is equal to 1. How will you get cofactors here? Again by same technique, it is minus 1 raised to 1 plus 1 into 1. See here we have to write minus 1 raised to, index is I plus j. I plus j means suffix here. It is 1, 1. So I plus j is 1 plus 1. So minus 1 raised to 1 plus 1 is plus 1. So you will get 1 here. Okay. Then our minor is minus 7, that is M12 is equal to minus 7. How will you get cofactor? See here, A12, that is equal to cofactor of A12. So index of minus 1 will be minus 1 raised to 1 plus 2 into minus 7. So minus 1 raised to 1 plus 2 is 3. 1 plus 2 is 3. So minus 1 raised to 3 is minus 1. So minus 1 into minus 7, that is plus 7. So minor is minus 7 and cofactor is 7. Similarly, third one, minor is minus 3. M13 is equal to minus 3. Then cofactor will be, see, minus 1 raised to 1 plus 3 into minus 1. Now check here, minus 1 raised to 1 plus 3 means minus 1 raised to 4. So that is plus 1. So plus 1 into minus 3 is minus 3. Okay, see here it is minus 3. M13 is minus 3 and A13 is equal to also minus 3. Correct? Minus 1 raised to 1 plus 3 into minus 3. Okay. Then M21. Next minor is M21, that is minus 5. Then cofactor A21 is equal to minus 1 raised to 2 plus 1 into minus 5. Now minus 1 raised to 2 plus 1 is minus 1 raised to 3. So minus 1 into minus 5, that is plus 5. Check this. Then next one M22, that is equal to minus 1, and cofactor A22 is given as minus 1 raised to 2 plus 2 into minus 1, but minus 1 raised to 2 plus 2 is plus 1. So plus 1 into minus 1, that is minus 1. Next M23, that is M23 is equal to minus 3. Check the cofactor. So cofactor A23, that is given by minus 1 raised to 2 plus 3 into minus 3. So minus 1 raised to 2 plus 3 is minus 1. So minus 1 into minus 3, that is plus 3. So here minor is minus 3 but cofactor is plus 3. Next one, see here minor M31, that is equal to 7. What about cofactor? See here minus 1 raised to 3 plus 1 into 7. But minus 1 raised to 3 plus 7 is plus 1. So plus 1 into 7, that is 7. Then M32 is equal to 5. Then cofactor is A32, that is equal to cofactor of A32 is equal to minus 1 raised to 3 plus 2 into 5. But minus 1 raised to 3 plus 2 means minus 1 raised to 5. Minus 1 raised to 5 means minus 1. So minus 1 into 5 is equal to minus 5. Then last one M33 is equal to minus 3. So its cofactor is again here minus 1 raised to 3 plus 3. So minus 1 raised to 6 is plus 1. So plus 1 into minus 3, that is equal to minus 3. So we get all the cofactors, all corresponding cofactors A11, A12, A13, A21, A22, A23, A31, A32 and A33. See all these are cofactors. Now we will find out the cofactors matrix. So matrix of cofactors can be found by using this general form. Okay. So here it is A11 is 1, A12 is 7. Now here A13 is actually minus 3. So here it is minus 3. So matrix of cofactors. See here 1, 7, minus 3. Then 5, minus 1, 3. 7, minus 5, minus 3. Now as we know that adjoint of the matrix is the transpose of cofactors matrix. So just take the transpose and we get the adjoint. So this is the adjoint 1, 5, 7, 7, -1, -5, -3, 3, -3, like this. Okay. So today we have discussed the concept minors and cofactors, then how to write the cofactors matrix, and how to find out the adjoint of the matrix. Now by using this adjoint, we will find out inverse of the given matrix. So the method is very easy method. In our next lecture, we will find out the inverse of given matrix by using adjoint method. Okay. So today only we have discussed how to get the adjoint of matrix. Okay. Thank you.